Hello, everyone. This is Jiming Sun. I'm a faculty member at the University of Illinois Urbana-Champaign, also the host for the AI for Healthcare webinar. And today we have a very special AI for Health webinar. And in fact, it will be a short presentation plus demo and then a panel discussion with all the contributor and developer for this open source PyHealth package. And I will actually hand it over to our main developer today, John and Jimbang, to organize or manage this session. And John, you guys want to introduce yourself and get started?
Yeah, okay, I'll start with myself and then I'll pass it off to Zinbang. My name is John. I'm currently a second-year PhD student in the Sunlab. I primarily work on rare diseases. One of the main projects I'm also working on is this package here, PyHealth, with Zinbang.
Hi everyone, I'm Jimbang. I'm currently a final year PhD student at Sunlab. My research mainly focusing on building foundation models for patient data, and I also work on building PyHealth. Nice to meet you, everyone.
I see some of our other contributors are here, especially external. Chaoqi, you want to introduce yourself? Good to see you back.
Oh, hello everyone. This is Chaoqi Yang, and I worked with Professor Jimin Song during my PhD, and I graduated from the lab last year. Right now, I work for Citadel Securities. And yes, initially I developed the PyHealth package with Zhengbang, I think 3 years ago in 2021 summer, I think, starting from there. 2020 or 2021, I forget. But yeah, it's nice to see a lot of new faces, and then I see a lot of new developments after I graduated from the lab. I'm very excited to see some good functionalities that John and Zhenbang will introduce today. Thank you.
And Chaoqi was the main contributor together with Zhenbang during his PhD. And I'm glad he can come back for this special session. And also I saw Junyi is here. Junyi, you want to introduce yourself?
Yeah, hello everyone. I'm Junyi Gao, and I'm currently a PhD student in the University of Edinburgh in UK. And then previously I worked with Professor Jimeng Sun during my master at Urbana-Champaign. And I also contribute to this PyHealth. I mainly work on clinical predictive modeling and clinical trials. And right now I'm actively looking forward to contribute more into PyHealth and maybe extend the PyHealth into some other languages such as the R language.
Yeah, Junyi has been a very close collaborator on research with our group, and we publish a lot of papers together, and he also an active contributor to this. I'm glad he's now actually leading some PyHealth extension to R, and that's quite exciting to see as well. Patrick, you're here, and you want to introduce yourself?
Sure. Yeah. So thank you, Professor and Zhenbang and John for hosting this webinar. So I'm Patrick. I'm now a computer science PhD at UIUC. And before that, I was building PyHealth when I was a master's student at UIC. And I built several things for the first version, like implementing some models, creating performance visualization, and implementing functions like pre-trained embeddings. Yeah. And nice to meet you all.
Cool. I saw Benjamin is also here. And Ben, you want to introduce yourself?
Yeah, thank you to the organizers for arranging this event. Right now, I work at KGAI as head of engineering there. When I started working on PyHealth, initially it was to just clean up some parts of the repo, but ultimately there was a lot of opportunity to build synthetic data generation pipelines. So that was primarily what I contributed. It was a great project to work with everybody here. It's a great treat. It's technically a very satisfying project. So yeah, thanks everyone.
And one unique, thing I want to mention about Ben is he was actually taking the course. I don't know how many audience today are coming from my course, Deep Learning for Healthcare or the Georgia Tech Big Data course. And Ben was one of the students when he first reached out to us and helped us on some of the PyHealth development work. And so I think a few years later, he continued working with us. We started a company together a couple of years ago, but also published quite a few papers along the way. So definitely we're hoping that more students like Ben from the class can actively participate, and also we think there will be quite a lot of value you can learn from this engagement as well. So with that, I think John and Jimbang has a lot of items you guys want to go over, but yeah, please go ahead.
Yeah. Of course, I guess I can move along this slide deck. We don't have to introduce ourselves again, but this is just in case we didn't. We're going to compliment all of the contributors to PyHealth. There's actually a lot more than just here today. But to go over what we're going to talk about today, we wanted to give a really good reason on why PyHealth. So why might you want to use our software package, and also why you might want to contribute. And there's a lot of challenges and motivations associated with it. We're also going to go through a panel discussion. We're going to have more of like a conversation type piece, and hopefully some members of the audience can join towards the end of this presentation. To explain why PyHealth, you have to ask the question of why is doing AI for health hard? And one of the key reasons is pre-processing the data is very difficult. These data sets are very complex. And I'm going to let Zinbang take over from here.
Sure. So in health data, compared to a lot of those really well-known benchmarks like ImageNet, health data is often much more complex and noisy. So here we overview an example patient trajectory. So basically during a patient interaction with the hospital or a pharmacy or clinics, a lot of different data of different modalities, types could be collected. For example, here we have some medical code data like conditions or procedures. Those are medical coding data. And we might also have some lab tests that will be like blood tests that will be irregular time series data. And we also have those procedures like CDs, like EEG or ECG scan. Those are regular time series data. And besides all this, we have medical imagings like CT scan, X-rays, or just free text like discharge notes, nursing notes. So those complex and multimodal data makes data pre-processing really, really difficult. And it often requires a lot of different procedures and different expertise to modeling those data. And depending on your task of interest, maybe you want to focus on medical imaging or biosignals or clinical notes. And this part is often really, really time consuming and requires a lot of expertise to process this data. Next slide, please. And in PyHealth, our philosophy to solve this problem is that no matter what kind of data you're working on, we try to simplify every patient representation as a sequence of events. So this sequence of events is ordered by the time step this event occurred. And each event can be of different types or of different modalities. For example, if we think of a hospital admission of a patient, that trajectory initially can be like a ED, emergency department admission. So that would be like admission type. Following that, there could be some dialysis, could be some prescription events, could be some X-ray events or like G events. And they could have different attributes. Like for a lab test event, the attributes could be like the blood gas, different electrolytes measurements. And for an X-ray event, the attribute would just be like the X-ray image itself. So in this way, we make it really, really flexible by representing each patient as a sequence of events. And this can scale to different data sets. Like if you're just working on a medical imaging data set, like consists of like a couple of medical imagings, in that case, we just represent each patient, like each sample in that data set will now just be a single patient. And that single patient will only have one event that would be that corresponding medical imaging. And if you're working on more complex data set, like a whole comprehensive EHR database, then this really allows you to model that database in a really unified UI. And so that's our first API, this patient API. And then given this patient, actually previous slide, please.
Okay.
Yeah, given this patient, we define a bunch of task functions that will extract samples from this patient. So the difference here is like sample is we transform this event sequence into a machine digestible format that is consists of some feature fields and some label field. And each feature field can be of different modality as well. And we will call different processors to handle those different modalities. Next slide, please. So given this high-level solution, here we highlight 3 specific things that PyHealth is very good at. First, usually if you play with those large-scale EHR database before, loading those data actually takes a lot of time, and it actually requires a lot of expertise for you to extract those data from a relational database. And with PyHealth, we make this step really simple. So basically, inside PyHealth, for a lot of commonly used databases, we define some config file for each of the dataset to tell PyHealth what specific feature we want to extract from each table in the relational database. For example, in the left panel here, from the ICU stay table, we gotta extract the patient based on subject ID. We gotta define the timestamp of each event as in time, and within that event, we're gonna extract the following attributes. And we have this for all the tables in that database. So next, if you want to extract a certain table from this Mimic4 database, all you need to do is just tell us what's the root path to this database, and then what are specific tables you want to extract from it. And basically, PyHealth will handle it from there. We will create a global event data frame that consists of all the patients. So this avoids the very expensive patient grouping or sorting, and then everything is lazy loaded. I'll explain this in the next slide momentarily. Next slide, please. So the reason why we want to do this global event data frame and then this lazy loading is that imagine you have a database with hundreds of thousands or even millions of patients. Then if you try to extract the patient event from there, the sorting and patient grouping actually takes a lot of time and is very memory consuming. So our solution to that is we make everything lazy loaded. So you won't actually do the reading the CSV file or reading the database or sorting the event sequence until you actually need it. So we provide the escape patient API, which will do the filter sorting on demand. And here we represent each patient class as a patient ID, which uniquely identify each patient. And then everything inside it will be stored in this data source attribute. So this data source is a event sequence. And then for this patient, we also offer this get events API, which will perform on-demand filtering and sort so that you can get a sequence of events within a specific time frame. For example, you might only want to look at events within the first 24 hours of ICU admission, or you might also want to look at events of a certain type, like all the medical imaging events. These are all handled by this get events API, and it's pretty fast using the Polar's backend to do the on-demand sorting and filtering. Next slide, please. The last thing we want to highlight here is, given this unified patient event sequence API, usually people need to define a lot of different tasks to perform pre-modeling on top of that. Specifically, each task requires some certain features and then some certain labels that we did output. So the way we handle this is we provide this task template, which allows you to customize multimodal tasks based on your need. So the core idea is that each task function take all the event sequence from a specific. For example, on the left panel here, this patient has 4 event types. It can be dialysis, can be lab test, procedure, and node, and each of them are of different modality. For example, the dialysis is probably medical code, lab test is time series, node is free text. And inside this task function, what you need to do is just to define the inclusion-exclusion criteria, basically what specific patients or events you want to exclude or include for this particular task, and the feature and the label. For example, the feature, you might only want to extract the first 24 hours within hospital admission, or you might want to extract from a span of a couple years. And then for the label, you also define it here in the task function. For example, you can define, if you want to do disease classification based on the lab test, we just extract the disease based on the all the diagnosis event. And inside the task function, you also need to specify the schema, basically what are the types of each feature field and label field. For example, here the input feature is the lab, which is of type time series, which is irregular time series. And then the output we want to predict is called disease. and its type is multi-label. So here we want to perform a multi-label time series classification. And PyHealth will take it from there, and it will directly call different processors to handle this different type of feature or label field. For example, for time series, you can use the processor to do like imputation, normalization, etc. And for multi-label processor, you might want the task to automatically convert this label field into a torch tensor that can be directly used by the matrix or the loss function. So that's the three highlights we have for the latest version of PyHealth. And in the end of this presentation, we will also, actually next slide please, we will showcase 4 use cases that you can use PyHealth with to model different model data, from medical code sequence to time series data to clinical NLP task. And we also showcase this really usable module of PyHealth that allows you to do code conversion between multiple coding standards. Thank you. And I will hand it over back to John.
Yeah, thanks, Zimbang. And then you might ask the question, okay, I have my data loaded. What next, right? And one of the key challenges here is, you usually want some type of baseline for your task. And this is where we go over a lot of the other things that PyHealth offers. We offer a lot of different tasks. We offer a lot of different models. And we offer also a lot of different medical standards that you can play around with. And the nice part about this is it lets you quickly adapt the samples that you've basically processed and then initialize whatever type of baseline models that you would typically want to compare against. In this case, we're showcasing a sample of different conditions, procedures, medications, and we're trying to predict for something like mortality, for example. Behind the scenes, what PyHealth does with these models that we've offered is it'll take each of the features and it'll initialize a separate module for each one of them. And once you pass all the features in, it'll aggregate them and do the classification task that you initially set out to do. And we just want to say this is quite flexible. You don't have to use PyHealth models. You can use PyTorch. Everything is very much interchangeable because part of the issue is we also build a lot of the models with PyTorch. And so if you want to combine and mix and match, for example, here for a retain layer, that's very, very easy and doable. And we also want to make a point that a lot of these things are very easily initialized. It's the same type of API call for multiple different types of models. And we're hoping to expand the number in the future. Other things we offer a nice little lightweight trainer function. It's very much like PyTorch Lightning. You again don't have to use it, but it's there just in case you want to do some type of logging and checkpointing. We also offer a nice comprehensive metrics class. And basically what it does is you can define a bunch of different metrics that you want to look at all at once, and it automatically compiles them and does the evaluation later. And then you say, okay, I have all these baselines. I've done the work. I've made my own model, and I've run the whole pipeline. Another problem you might run into is your work is kind of lost in an ocean of what I would call a bunch of AI4Health works. This is something we scraped. We had a study that we ran a couple months ago, where we kind of measured the number of papers from these healthcare conference venues and as well as PubMeds. And so the number of AI4Health papers are very much on the rise. But the interesting thing about it is when you dig deeper into what these papers and the metrics that are behind them, and you look at, okay, how many times did this paper get cited, compare whether or not they share code. One of the key indicators was there was a statistically significant difference between those that did share code and those that didn't. And so there's a direct incentive for you, somebody who's doing all this hard work, to share your code. And the nice part about PyHealth is it offers kind of a nice publicly available centralized platform to share your work. We're trying to make it, a lot of the key changes that Zimbang outlined earlier were to basically make it easier for you to port your stuff to PyHealth. And we'd love to give a lot of people credit for this. One of the things we're running right now on our end, this reproducibility course project and the Deep Learning for Healthcare course. I just want to give credit to the 300 or so students that are tasked with reproducing about 160-ish of those papers that we've scraped from PubMed and these healthcare conferences. And one of the things they're tasked with is each group is going to contribute, some type of pull request at PyHealth. The nice thing about that is we're going to be able to actively stress test, how expandable is PyHealth. And then on top of that, we're going to plan to expand PyHealth a lot more beyond what it currently offers. To showcase further, what it currently offers, we have a bunch of use cases that we'd like to demo. I believe Zimbang, you start off with the first two. I guess I can click on the demo button.
Yeah, thanks, John. I think maybe due to time constraint, actually, let's not excuse those. Let's just go through. Basically, we will share this Colab notebook we see on the ReaderDoc website of PyHealth. And here, the first use case we want to demonstrate here is a sequence classification task with PyHealth. So basically, we are using the Mimic4 database, which is a EHR database for a lot of ICU patients. And what we want to predict here is we input the medical codes for each patient. Basically, the medical codes include some dialysis code, some treatment code and some prescription code that's usually used in the building and generated in the end of a hospital admission. And then what we try to predict here is readmission in the hospital.
Before you guys continue, do you think you can share the link to the chat so people on the online can just try it and check out the code themselves?
Give me 1 second. Let me share the link. Okay,
This one, I think, it should be at the view.
Yeah, thanks, John. Yes. Yeah, so feel free to explore it. We will handle the environment setup, data loading automatically for you in the environment setup. And for this particular task, we use the Mimic for demo dataset, which is publicly accessible. But it is a small dataset of about 100 patients, so it's pretty fast if you want to try it. So for this task, we try to predict readmission. Basically, when the patient is discharged, we take all the building codes for this particular patient and then try to predict whether this patient will be readmitted back to the ICU in the next 30 days. And to do this, we follow a 5-stage machine learning pipeline, where in the first step is to load data. Okay, let's go to step 1. So basically, you probably find this very similar. In the previous slide, we load this Mimic for data set and specify these are the 4 tables we want to extract from it. And this loading is pretty fast. If you execute it, you will notice it's probably run within 1-2 seconds because it's actually not do the loading. It's actually only do a lazy scanning. And the actual data loading will happen on demand when you actually query something from a specific patient or query some statistics. For example, you can use this get patient and get events API to actually load the data from the disk and do the sorting. So the output of this get patient is an event sequence ordered by the time step. So you can say each event have a event type, have a timestamp, and have a attribute dig, which is unique to that type of events. And once you load this into a unified API, the next step is to define the task. And for this particular task, we have defined the task template for you. You can just simply load it from PyHealth. Can you scroll down a little bit?
Yes.
So in this second step, basically you just need to import the task from the PyHealth task function. Here we use a readmission 30 days Mimic for task and set the task to this dataset. Basically, if you iterate through each patient and convert it to a list of samples. And for this particular task, we got 186 samples out of 100 patients because each patient can have more than 1 admission. And here we define each sample as a single admission. And if you look into what a sample looks like, it's actually a dictionary with different fields. So there are feature fields such as conditions, procedure, and drugs, which is already converted to tensor, which is machine digestible. And we have the label field, which is readmission, and it's a binary label. And then we will use the utility function to do the split and data loading. And then to define the model, here we just simply import the RNN model, and then we input the samples to this model. Basically, this model will be automatically initiated based on the input and output schema we define in the task function. As you can see, if you look at the model architecture, we have 3 RNN modules initialized for different inputs, and then the output is a binary probability. For the training, we use the PyHealth trainer, which you can specify a lot more hyperparameters, but here we just keep it fixed. We monitor the AOC score, and then to actually start a training, you can just simply call trainer.train and specify what are the train loader and validation loader, and what epochs, how many epochs do you want to run, and generate some hyperparameters. And in the end, you can do an evaluation with the PyHealth metric function. And basically, it will have a lot of different metrics you can call. Here, we just only specify call the AOC function, and then it will report the final metrics. Here, the result isn't very good because this data set is pretty small, so different splits tend to have a very large variations. But if you have access to the whole Mimic for database, you can run it with it, and then the results will be more meaningful. So that's the sequence classification task. And the next use case I want to show here is a medical time series classification task to do in-hospital mortality prediction. And you can also just go to this Colab page. Let me share the link as well.
It should already be shared, Zimbang, but
Oh, okay, great. Yeah.
yeah, I think we've shared 3 of at least the demos that we're going to go through. I don't know if we want to go through each of the tests. They're all very much the same.
Yeah, they're pretty much the same. And the only difference is here we just specify another task function. And if you actually go to this task function, you will see we do different cohort inclusion, exclusion, and different feature processing. And then the output, if you look at the samples, you see it's actually each sample looks different. Now the samples is a irregular time series. And we would automatically call the processors to convert this irregular time series into a regular one by doing the resampling, imputation, and normalization. And you can still use the RNN model to do this task, and then the training and evaluation remains pretty much the same. So with that, you can use the same base data set, and just on top of it, you can define multiple different tasks on top of it, and then load the PyHealth model to do the prediction. So that's the 2 use cases. Next, I'll hand it over to John to introduce NLP use case.
Yeah, so one of the things I used to work on was medical coding. In particular, you take basically a set of clinical text, so you have clinical notes, particularly again from the Mimic database, and you try to predict different ICD codes that are associated with each of these patients. And I can go through the demo. It's the same thing. Again, the APIs all very much function the same. You load the bottle, you load the data. In this case, the only difference here is we defined a node events table in our table, set of tables that we want. We call this again so we can do the processing. And again, right, we do this thing where we have a set of tasks. We call this Mimic 3 ICD coding task, and it's quite nice, and it does the thing, processes it. Now it's machine readable. It has the multi-label tensors, the text length. We have all these things. Here's an example of some clinical text. Typically, how you might want to do this is you might want to use a language model. And so this is where the nice thing about Hugging Face or Help's flexibility is that if you want to use a Hugging Face model, you can. We do offer our own little wrapper function for it, but you don't actually have to use it depending on what your use cases are. Again, defining your metrics. In this case, we have the F1s, micros, and the macros. When we get F1s, you can evaluate using these metrics. Now you can train with the trainer if you want to use the trainer. And again, evaluation towards the end. I want to say this is a synthetic data set. We're not actually allowed to show real notes. And so you might find that if you do run this demo, it might not give you such great performance, nor will it translate the real world medical coding. But it's still nice that we're able to do this now. The final use case I wanted to show is something called medcode. I think we previously mentioned this. There's all these different types of codes that label all the different types of procedures and conditions. And there are many different coding systems, right? And so, the question is, okay, how do I identify what each of these codes are? What coding system are they part of? And also, can I translate in between different coding systems? I don't know if we have use case for this, but medcode, if you look at our documentation, will let you look up these things and translate between the ICD and CCS. I guess we can move on. Oh, yes, Holland, yes. We'll share the link after, I guess, the presentation. To move on to the panel discussion, I'm happy everybody already introduced themselves. That was what I was going to first ask Xiaoxi.
John, before we go to the panel phase, it would be good if you can, do you have all this Discord mailing list? How do people get involved or contribute?
Yes.
Do you want to talk about that first before we go to the panel discussion?
Let me break out of this. So if you go to our website, we're slowly updating the documentation. So in some sense, we have this nice new backend that we need to add additional documentation to, but we do have a Discord server. So I'm going to post this link in the chat for anybody who's curious. One of the things we want to do is build a community around PyHealth, especially just to see what goes wrong. A lot of times on GitHub issues, like we might get really busy, and then sometimes we might forget that GitHub, you make an issue on GitHub, it can take for a while to get back to you guys. But if you're on Discord, it's much more personal. You can directly reach out to us. We also have a mailing list. So if you do want to see all the new updates, for instance, in this case, we're going to be releasing essentially a PyHealth 2.0. That'll make PyHealth a lot easier and more bearable to use. And so on top of all these additions, some of the changes might be coming from the course reproducibility project. So we might support some of the models that you care about. Generally speaking, we're going to keep updating these read the docs, and we're also reaching out on Discord, which to us, I think we used to have a Slack channel for some of the people who were here much earlier with PyHealth. Unfortunately, Slack is not very scalable, whereas Discord lets us do a lot of other things on top of it.
Do you want to show the Discord?
Sure. Let's see if I can't open the Discord app. It has to be a student email. No, I don't think so. It should support all kinds of emails. If it doesn't, let me know, see if I can't date these things. Yeah, I can share the Discord. So one of the things we want to talk about with Discord, you'll see that there's also a section, if you're not a student, you won't be able to see much of these channels. But if you are, you'll get access to the Deep Learning for Healthcare Reproducibility Project section. One of the things we wanted to do was give an avenue for people to reach out, ask questions, make, issues. So if you have a big problem with PyHealth, I was looking into something with one of the EEG data sets that we typically allow people to load, but for some reason, we're having issues with that. Review requests. So for those who are looking to contribute and they want a reviewer to look at their things, we have a how to contribute guide for those who want to get started, who aren't too familiar with Git, for students out there. If you want to introduce yourself, that would be great. We'd love to get to know you. Just be smart. And one of the things I do want to say, if you do join, clicking one of these roles will help us identify, what kind of, whether or not you're interested in being a contributor or if you're a student for some of the other things that we're doing here. I guess one of the big goals about building this community is we want to find people who are dedicated to PyHealth. And on top of that, what that means is finding other reviewers. So currently right now, I think Zimbong and I are one of the only ones who are actively engaged in trying to get pull requests done and things that contribute to PyHealth. It would be nice to expand the team a bit. So for those that are really interested, please don't hesitate to reach out. There's a lot to do, so.
So there's a question, Aaron, asking how to deploy this with the real-world medical data. That's a good question. I think the easiest way will be for you to set up PyHealth in your local environment where you have access to that your proprietary medical data, and you probably have to export those data to some files or to CSV or some files, so then you can use PyHealth to process that. So just like how you use Python, R, or whatever data science software locally with your hot medical data.
Yeah.
Yes, actually to add more onto this. So I don't know what specific data format you used in the on-prem data, but here with PyHealth, the backend is actually Polars, which is a data frame library. So assuming if your data is like a CSV file, Parquet, or Feather file, JSON file, you should be able to load it with the same Polars backend. And basically what you do is to specify something like this YAML config. I should send a link to the chat and just tell us what specific table you want to load and what are the specific attributes you want to load from each table. And we will build an event stream from there. But right now we don't actually support other systems like Epic or other, like if you use like a local database, probably you need some like connector, which I believe we don't have at the moment, but I think that's something we might consider in the future. Thanks.
Cool. Yeah, just feel free to ask questions on the chat, by the way. And if not, we can switch to the panel.
Yeah. I guess we can go in order of the people that the speakers we invited of Xiaoqi, Juni, Patrick, and Benjamin. If you don't have anything to say, you can say you don't have anything to say. But I think one of the questions I always had, I was the new PhD student when Xiaoqi graduated, and I never got to meet you, Juni, until a couple months ago, which has been really cool. But basically, why did you guys start PyHealth? I think there's a lot of questions around. At least to me, it wasn't obvious. Like how you guys would get together. You guys are all very busy people doing a lot of research. What was the motivation behind why you guys set the foundation for something that, in my opinion, has been very useful?
I can speak for that. I think that's the initial idea of PyHealth can date back to several years ago, and back then there are a lot of like Python related healthcare or medical packages out there. Like the open source is like very popular back then, and the professor brings up like, why can't we do something like this? And And I think back then we are all doing healthcare research like traditional ones. There's no large language models yet, and we do clinical predictive models, and we use some common data sets such as like Mimic3, EICU. Those are the typical data set, and people use them like heavily in a lot of papers. But even for the same tasks such as readmission prediction, mortality prediction, everybody have their own definitions. So we wanted, and it's quite hard to benchmark different tasks, and we wanted to set up a benchmark, set up like a real baseline, like everybody is agreeing on, and that's why we wanted to have a standardized like data processing pipeline, and how to define the task in a way that everybody agreeing on. So that's why we start some initial task with readmission prediction, mortality prediction, and also on some EEG data sets, like the sleep EDF, I guess that's the name. And after that, I think that the initial work is done by me and Zhenbang. So that's kind of the first motivation. The second motivation is I think at that time I was intern in a tech firm, and I started to build on top of some large scale like code base. And it's also for my personal reason. I wanted to like enhance my skill set on like how to develop large scale software, something like that. I think this is Professor brings up this idea. So we think this is this aligns with both my own like career development plan, and like also follows the trend of how the research in this domain is happening, and that's naturally we start to do this pipeline. I'm not sure how Zhenbang's idea is, but that's pretty much my motivation.
How did you guys convince Junyi and Patrick and Benjamin to jump in? I'm curious about their stories.
Yeah.
I don't get to talk to these other three, so.
Yeah, I agree with Chaoqi. Yeah, I think we have been doing the healthcare research for many years, and I think when you are new to this area, there are so many papers, so many data sets, and each data set is huge. Like Mimic3 and Mimic4, they are huge. They have many tables, and in each table there are like millions of rows. And when you just enter into this area, maybe you have no idea how to like process it, which features are useful, and even like if you are not even in the medical field, it is more difficult to understand like what features are predictive, or how can we process this temporal or non-temporal features, this multimodal features. So what we want to do is to build a software, a toolkit to help anyone in this field, including ourselves, to easily to handle this complex data set. We can write several lines of code handling a very complex data structure or some data sets, and this code and all these models are reproducible, and this model code we can reuse them and to further boost the research. Yes, I think that's a very useful tools for all researchers in this field, the beginners or the senior researchers. I think they would be useful for all of us. Yeah.
Patrick, what about you? I think you're very like you work on very distinct things. Actually, I feel.
Yeah. So my motivation was pretty simple. So when I got admitted to UIUC as a master's student, I actually didn't know what to do or what I could do, like besides taking courses and doing homework. Even as a thesis-based master's student, and I was really worried about my thesis because I have very limited research experience. So Professor Sang actually suggested me, like, why not join Chaoqi and Zhenbang building PyHealth? And I said, okay, even though I didn't know what I was supposed to do, or even at that time point, I didn't even know how to code in Python, since I was a Java programmer before that. So when I was building PyHealth with Zhenbang and Chaoqi, I feel this was really something, because it actually provides a consistent or centralized experimental environment for all the approaches proposed by different academic papers. And I felt like PyHealth would become known by everyone in this field because academic papers often suffer, from the reproducibility problem, and even when they can be like reproduced, the results are not able to be like directly compared because they may have some fundamental differences in the experiment setting. So yeah, that's basically it for my motivation and the story. Yeah.
I had no idea you didn't know how to code in Python, considering how productive you are in our lab. So I'm very impressed.
That experience is very good.
Yeah, maybe I can add my experience too. Is basically at the time that I started on the project, I was a remote master's student. So I was in the online deep learning for healthcare course through the MCS program. And I was very much a beginner in machine learning, so I couldn't really contribute heavily on the model side, but I had worked as a software engineer at the time. So I wanted to like somehow find some way to get the professor's attention. So I looked through the code base and there's like some simple things I could fix, software and like traditional software engineering tasks, like making unit tests, for example. And then I think Chao-Chi saw the pull request and maybe mentioned something to Professor Sun. And then I was kind of given the opportunity to build a basically machine learning pipeline. And so for the synthetic data generation. And so this is actually like an exceptionally useful hands-on experience for building an ML pipeline, and the architecture is based on language model, like I think GPT-2. So it was a really great project for me from a learning perspective. And then it's very simple to see kind of the themes that everybody else is discussing with reproducibility and standardizing data processing. So it was just a good project to kind of join in on at that point. But for me, it was like my entry point into actually doing machine learning.
I want to maybe just comment on what Ben says there. In fact, on a day-to-day basis, I receive around 5 to 10 emails from students who want to do research with our group. And I reply to most of them. I always said, okay, here's PyHealth, go check it out and contribute. And I think very few people actually contributed or take any actions. Even things like what Ben says, right? I think everybody can contribute to some extent, right? You can even write some comments, add some unit tests, right? I don't think it requires a lot to contribute, but vast majority never contributed. So I think could be something we should improve more to make it easier for people to contribute. But also, as I felt, for anyone are interested in contributors, there's clear value even for a simple unit test. I think when I still remember when Chao-Chi reached out to me saying, "Oh, there's a master students, writing unit tests for us, and should we engage with him more?" I'm very excited. Of course, most of the people, if you ask them, give them those tasks, they feel like, "Oh, that seems pretty far from publish a paper. I want to publish a paper." That's why I reach out to you. But the fact is, most of the folks who engage with us initially kind of far from publish a paper. You cannot just, let's write paper day one, right? You have to really understand the space. And by now, I think Ben already not even working heavily on the research side, published like 7 papers already with us. So, I felt you just have to get to work and get involved. But John, please continue with
Sure. I think, I don't know if this is a good question, but one of the things I was at least surprised to hear about, because a lot of people do a lot of open source software, but it never takes off. And I think Chao-Chi, you said something about when you were kind of advertised it to us junior PhD students at the time. But I want to posit this question again. Was there anything surprising about PyHealth to you at the time? Like, did you expect this software to survive? Did you, I think, at least to me, it seems very surprising that Patrick can go from using only Java to working now writing a bunch of NeurIPS papers that I'm consistently reading about these days. So,
well, that's a good question, but it's hard to answer. If you ask me what is surprising back then is, you can imagine when you are doing some project with one or two speakers, then gradually a lot of people join you. Gradually you can publicize this to the public, and a lot of people that are interested, they contact you, wanted to know more about this, wanted to download this on their own software and ask you how to use it. It's a very exciting experience. And if you keep getting like external impulse from in different ways, then this will be a push. This will be a motivation to push yourself to make it better, to satisfy all different needs of the users, to expand the user range, and to ask more people to join you, and then collectively you guys can build a more or better comprehensive packages. I think after I listened to the thing you presented before these panels, there are already some new functionalities that we wanted to implement, but I haven't before I graduate. That is the multimodality stuff and how to handle large scale data set. I haven't done that like before graduation, but this is something that is already finished right now, which is a very exciting progress. Even I graduate, I haven't been engaged in this project for like 1 year, but I see there are new functions that is being implemented in the package, and still a lot of people are maintaining that. A lot of people are interested in that. Even now I work in the firm, still some people they contact me like personally, send me emails or add me WeChat, ask about like whether you guys can add these functions to the package, or like can you guide me how to deploy that in my system, something like that. Well, I think it's very, very like satisfying. Like when you begin this project, you will never know what will happen. It's like it's just like doing a startup. In the beginning, it's driven by your own motivation, by your own passions, but later, like everything can happen.
Can you say more? Maybe
I've never talked to Junyi about PyHealth, but I guess I kind of ask the same question to you because you're also one of the more senior people, like who was there. I'm assuming from the beginning, right? Were you there with Xiaoqi?
I actually not. I contribute a lot to the clinical predictive modeling as some model, but all many other models are like led by Chaoqi. But I'm still surprised by the impact and the contributor of the PyHealth. I see a lot of people are using this, and a lot of people are actually involved in this. And yeah, I think I see how impact a well-organized toolkit can be. Yeah, and that's why I want to like publicize this more and maybe into other languages. Like in R, like there are many statisticians and clinical doctors at least in UK, they are using R. Actually, many healthcare servers in UK, they don't have Python installed, so they have to use R. So that's why I want to like broadcast this into a further to a larger like user group. Yeah.
I think I don't know if I want to ask the same question to Patrick and Benjamin. So if you guys want to shake your head, no. But I don't know, Patrick. You just unmuted yourself, so I'm curious if you have anything to say.
Yeah, just in short. So actually, PyHealth opened the door for me for like research, and I learned a lot from like collaborating with Chaoqi and Zhengbang, because I actually wrote a bunch of bad code like during that time, and keep being rejected by them. But I actually learned the coding standards like in such an open source project. Yeah, so I really appreciate that. Yeah.
one thing I want to ask, maybe whoever, maybe Chaoqi or Jinbao or maybe John, you guys, because you guys are heavily involved in this, right? Not, I mean, even in my lab where there are 10 other people probably, but the people who really spend a lot of effort on PyHealth is still quite small. I can see from their perspective that's okay. Seems like a extra big overhead on top of the research work I'm doing today, and or I already have my own setup. That's kind of that's things I need for the research I do. I don't really need to learn or use PyHealth. How do you? What's your take on that, or do you see some benefits doing this on top of there's a lot of people who kind of reach out to you and you felt like, okay, this is some real world impact? Are there also direct benefit to your own research, or how can you convince more PhD students to join this?
I think previously, actually, I don't know, does someone want to say something? I'm happy to.
You can go first. You can go first.
I guess when I was doing it, I was like, everybody in the lab does clinical NLP, but PyHealth doesn't support clinical NLP, right? And then so the question was, for me at least, it seemed it was very hard to convince people to directly jump on the ship if they, because everybody in our lab is very busy, right? So it's very, and so the benefit of PyHealth, at least to me at the time, was, okay, how can I get to a point where it's like, with Xinbang's new change, right? I can process the data super fast. Now I don't have to worry so much on the back end things. I don't have to do it manually by myself every time. There were issues with, okay, I'm working with clinical notes. Like there were just, previously it was very hard to support different modalities, but now we can do pretty much all of them. And so, if you want to combine EEGs with clinical notes or radiology reports with x-rays, right? It's quite possible. And so it opens a lot of questions that PhD students want to ask, right? How, between the modalities, do I want to build bigger models? Sorry, Chashi, go ahead. I think you're...
Sure. I think I probably have some more more high level, or not like the thinkings why I want to do this package before. I think at that stage, I think I got enough paper published. So I'm thinking, how should I compare myself with other very famous, very competitive PhDs back then? I think in the current stage, a lot of research papers are not, will not stand yourself out of all these different competitors. You need to be strong in research and also some other skill sets. And I realized back then a lot of PhDs, they have successful open source softwares as well. So they are strong in all aspects. That's how I compare with them. I think I need to do something like that because I don't think I have done some open source or large scale project before. I wanted to train myself, both put it on my resume to make it stronger. That's the very direct motivation, one of the direct motivation. Also, I was doing this clinical predictive model research before, and in every project I have different pre-processing scripts, which makes me feel annoying. I have to clean them up every time. So maybe clean them up and collect them together into a package is a good way to structure your own research and reuse the previous models for new papers or new projects. That's another direct benefit I got from the package.
What about Jinbao? What's your any experience you want to share?
I think I agree to what John and Chaoqi have been said. And I think personally, I feel like building PyHealth really helps your just fresh your engineering skill. And I know for some, for the researchers, sometimes we think, hey, I don't want to do engineering. things. I just want to purely do research. But I feel like currently the line between research and engineering is actually getting more and more mixed together, especially if you're working on like LLM stuff. Basically, a lot of things you do are engineering works. And I think working on PyHealth can really enhance your capability on that, because now for research, sometimes we don't really care about like flexibility or scalability, since we probably only do it once for this project, and then for other project we're gonna do something else. But if you work on PyHealth that's designed for different tasks and for different users, you really need to think about those questions, and you also need to refer to a lot of different more like popular packages like transformers, polars. So this really gives you a lot of opportunities to learn from them how to do like develop a package properly, make it scalable, make it flexible. And I think I learned a lot during this process. And the skill you learn here will actually transfer to your research when you're writing code. And I think that's the key benefits.
Help you or in any way for, I know both Chaoqi and Jinbao, you're both are heading either in industry or heading to industry. Do you have any benefit from just by working on PyHealth, or just getting those industry positions? Or
yeah, I think let alone all the indirect benefits where you learn ability skills. I think if you end goal is to go to industry and you're a PhD researcher, I think having some open source contributions and maybe having a library with a couple 100,000 stars can really set you different compared to all the other interviewees, because many PhD students have multiple papers, but not all of them have like a open source contribution with a lot of stars. And I think this really draws you different. And also, if you want to apply for some jobs in the health tech, I think many companies, they already know about PyHealth or they're using PyHealth. So also they get to know you even before they meet you. So that's actually a big plus if you want to go to industry. I don't know, Chelsea, if you have anything else?
I can share my experience. So I think first of all, right now, even in this large language model like area, I think I heard from a lot of my friends from OpenAI and Therapeutic, their opinion is research is not as important as engineering skills. Right now, what makes it successful is a good pipeline that can train large scale models. So engineering skill is definitely very important, like even for now practically. And I currently work as a quantitative researcher in the firm. What I do is I build machine learning, deep learning models and train on financial data. But I still need to code a lot during my work, and a lot of research iterations is successful when you can write your code correctly. You can structure the code in an efficient way and iterate it in parallel. So engineering skill is definitely very useful, and I got a lot of intuitions, good engineering skills from the PyHealth project. And some direct benefit from PyHealth is back then when I was trying to find at my final year trying to find my internship. I find an internship, there's a lot of hiring freeze, and I interviewed some big tech, but they I never heard back. They didn't reject me. They didn't get me offers. And then I interviewed with the current firm. They give me they talked about this package with me. They are impressed that we write a lot of code from this project, and which is a good differentiator between me and other candidates. So they start to give me a chance. They think I'm very practical. And after I joined the internship, I showed them I can build good softwares compared with the employees they already have in the firm. Most of them are from very theoretical background. So that's a differentiator of me, which directly benefit me in my current job.
I think if it's okay, Professor, we can answer some audience questions now.
Yes.
I think Jizang, I don't know if you have a microphone, but he asks, why don't you work in healthcare after your PhD, Xiaoqi?
Oh, yeah, I was about to apply that in chat, but I can say that. I think it's it's not an absolute question why I don't work in healthcare. I might come back to healthcare industry or come back to or general tech industry later. I think this is just the decisions I made back then. The tech the tech area is not a very good opportunity back then for me. A lot of hiring freeze, and if I decide to go to the tech firms or healthcare firms, they probably won't give me a big package because of these hyper of like large language models. I'm not doing in that field. So then I got good opportunities. I got a return offer from my internship. So I decided to take a look what is this mysterious like industry, and then that's pretty much my like why I made the decision back then. But it can be a good decision or a bad decision if we discuss it again in 10 years. But who knows? Yeah. Oh, but always like back to healthcare or back to general tech firms are always a backup plan for me, as long as always keep up with the newest development in the tech and keep up with keep practicing your engineering skills.
I think Howlin had a question. I'll reiterate Zimbang's response. When you mentioned Mimic 4 dataset earlier, does it include extensions like CXR? Yes. So the main branch, if you do clone it, you'll see that it does support CXR. If you pip install it right now, because we haven't updated the PyPy release yet, you won't be able to use CXR. So for those that are interested in using it with X-rays and notes, we would recommend you guys just cloning the repo for now. Zore, could you please provide some information regarding the final project expectations? Yeah, I think I wouldn't worry too much about it. Just try your best. I don't know if it's relevant to this webinar. I can put some more details later. Anybody else have any other questions? Otherwise, I feel like we're very much over time in the webinar.
Okay. If not, maybe I think we can wrap. And the key, there's some links, right? We should share. People should sign up the mailing list and get on the Discord. Probably do both because you may not check Discord that regularly, so we can also remind you there are some updates, and be good to keep in touch that way. And thanks John and Jimbang for organizing this. Thanks, everyone, Chaoqi, Junyi, Patrick, Ben. I know you guys are quite busy and coming back to attend this. I appreciate everyone's participation. Thank you, everyone.
Take care, everybody. It's nice to see everybody again.
Bye-bye.
Yeah.
Thank you. Bye.